Welcome to Astronomy Daily, your go-to source for the latest updates in space and astronomy. I'm your host, Anna. Today, we have a compelling lineup of stories for you. First, we'll dive into China's Chang'e 6 mission, which is preparing for an ambitious sample return mission on the far side of the moon. Next, we'll explore how NASA's Roman Space Telescope and its innovative coronagraph instrument could revolutionize our ability to image distant planets. Also on the agenda, we'll discuss how dimming plant glow, detectable via satellite, can serve as an early warning system for flash droughts, a discovery that could have significant implications for agriculture. These are just a few of the fascinating topics we'll cover, so stay tuned for an engaging and enlightening episode.
The Astronomy Daily Podcast.
China's Chang'e 6 mission is gearing up for an ambitious sample return mission on the far side of the moon. The spacecraft is currently in orbit, busily scouting landing sites in the South Pole Aitken Basin, one of the moon's oldest and largest impact structures. Scheduled to touch down in early June, Chang'e 6 will drill into the lunar surface to collect rock and soil samples. Within 48 hours of landing, these valuable lunar specimens will be loaded onto an ascender that will dock with the orbiter for the return journey to Earth. The entire mission will last 53 days, culminating with the return capsule landing in China's Inner Mongolia region, bringing back these unprecedented samples for scientific study. The Nancy Grace Roman Space Telescope is on the verge of deploying groundbreaking technology with its coronagraph instrument, which aims to transform how we image distant planets. The coronagraph instrument functions by blocking the overwhelming light from stars, thereby allowing astronomers to detect the faint glow of planets that would otherwise remain hidden in the glare. This innovative technology, known as the Roman coronagraph, utilizes advanced tools to achieve its goal. Key components include deformable mirrors backed by thousands of tiny pistons, which adjust to block out unwanted starlight more effectively than ever before. This active coronagraph can make precise changes to compensate for imperfections in the telescope's optics, a critical capability for observing planets that are billions of times dimmer than their parent stars. By enhancing the ability to directly image exoplanets, the Roman coronagraph instrument will significantly aid the search for habitable worlds. It will demonstrate techniques that future missions can build upon to eventually detect Earth-like planets in habitable zones around sun-like stars. This undertaking marks a monumental step forward in our quest to find life beyond our solar system. Flash droughts here on Earth are incredibly challenging to predict, as they develop rapidly and can cause significant agricultural damage. However, scientists at NASA have made a groundbreaking discovery that could change the game. Utilizing satellite data, they've found that the dimming glow of plants, an indication not visible to the human eye, can serve as an early warning signal for these sudden droughts. This glow, known as solar-induced fluorescence, diminishes as plants experience moisture stress, providing crucial data weeks, sometimes even months, before a flash drought occurs. This early detection system could be a game changer for farmers and communities, allowing them to take proactive measures to mitigate the impact of these sudden weather events. The U.S. Space Force is exploring new frontiers in satellite maintenance with Starfish Space's Otter spacecraft. This mission represents a significant leap forward in satellite servicing technology. The Otter is designed to autonomously rendezvous, dock, and provide additional propulsion to satellites that were never originally equipped for such maneuvers. By attaching itself to these satellites, the Otter can extend their life and enhance their maneuverability, effectively boosting their operational lifespan by up to 2 years. This initiative underscores the growing importance of in-orbit servicing, ensuring that our satellite infrastructure remains robust and flexible in the ever-evolving space environment. The UK space industry is gearing up for new launches with developments across various spaceports. One significant milestone comes from rocket factory Augsburg, RFA, which recently conducted successful static fire tests of its RFA-1 rocket at Saxavord Spaceport in Shetland. This marks a crucial step towards the first vertical orbital launch from the UK. The stainless steel constructed first stage of the RFA-1 underwent a 20-second hot fire test, where its helix engines were ignited in sequence, demonstrating flawless performance. Saxavord Spaceport has also obtained the necessary licenses from the Civil Aviation Authority, bringing it closer to becoming fully operational. If all goes according to plan, the first vertical orbital launch from this site could take place as early as September. Other UK spaceport projects include Sutherland Spaceport, which has started construction under the management of Orbex, and Prestwick Spaceport, which aims to rival Cornwall in the horizontal launch market. These advancements mark an exciting time for the UK's growing space sector. NASA's latest heliophysics experiment is setting the stage for groundbreaking discoveries as it prepares to hitch a ride on a European mission aimed at studying the sun. This collaborative effort is designed to deepen our understanding of solar phenomena, which include solar flares and coronal mass ejections, events that can have significant impacts on space weather. Space weather affects a variety of human technologies, such as satellites and communication systems, making this research critically important. By investigating the sun's behavior more closely, NASA and its European partners hope to develop better predictive models, ultimately improving the resilience of our technological infrastructure against solar disruptions. This experiment represents a promising step forward in safeguarding our increasingly interconnected planet. Thank you for joining us on this episode of Astronomy Daily. Remember to visit our website, astronomydaily.io, for the latest space news and updates. There, you can also sign up for our free daily newsletter, listen to all our back episodes, and explore our constantly updating newsfeed. Don't miss out on exclusive sponsor deals from NordPass, NordVPN, ProtonMail, Amazon, and more. Once again, I'm Anna, and we'll be back soon with more exciting updates from the world of space and astronomy. Thanks for listening.